After downloading the repository from my GitHub account, you can change the directory into that folder, and you can go into the bin folder, and I have two main executables here: the infix to postfix conversion, and also another one to calculate the postfix expression. So to run it, you can type that command into the command line, and you can input a normal expression separated by a space and press enter, and you can press next to go to the next step, and you can also go back to the previous step by pressing the back option. Now when all the steps are finished, it prints out the result, which is the final postfix expression corresponding to the input that was inputted by the user. You can continue to input another new expression, or you can press Q to quit. Now for the calculator, it does the same thing, except that this one now calculates the postfix expression. So you also have to remember to separate the numbers and operator with a space. Our final answer will be -4. One of the limitations for both converter and the calculator is that it does not verify the correctness of the expression. So if you put anything that is not a postfix expression, it will eventually return error, because the validator is not included in this executables. And that is for the executables. And to explain the organization of the code, it has a couple of folders inside the repo. The main ones are the bin directory, which you just saw. It contains the executable files, and the main code is included in the library lib directory. So this RPN UIA, which stands for reverse Polish notation, which is a synonym for postfix expression. This one contains all of the code necessary to run the executables. So these are all of the classes included in the package. The most important ones are the CLI, command line interface class, which is the main driver code for the executable file you just saw just now. So this one does ask the user for the expression, and depending on whether the user chose next or back or quit, it does a different action and display the title in the table. And another important one is the table, which is responsible for rendering the table, the columns and the table header. And converter and the calculator is basically an iterator that iterates over the steps that is necessary to either convert the infix expression to a postfix one, or the calculator that calculates the expression step by step. So either of these classes implement a next method and back method that that moves to the next step or go back to the previous step, and each of it has a different algorithm inside the next method. The operator class contains the valid operator allowed in each of the iterator when the next method is called. So, and it also is defined the strength for each operator. As you can see, the exponential operator has the highest strength with 2, and multiplication and division and remainder operator has the strength of 1, and the plus and minus has the weakest. And this operator is the one responsible to compare two operators, whether one is stronger than the other, and it returns 1, 0, or -1 depending on the strength of either the left one or the right one is stronger. And it is used inside both converter and also the calculator. If you go to the executable file, so this is for the converter, it has a title and the converter class that is injected into the CLI class to run the method. And as for the calculator, it has a different title, and we inject a different class, which this time is a calculator, to the CLI run method, which then executes the sequence of the conversion, and in this one, calculation. Another folder included in this project is the spec file, which contains all of the test code to verify the functionality of each of the method in every class inside this project. So let me try. Let's see the converter class, and let's open up a spec file for the converter class. And it has a different file depending on different method. I'm gonna choose next spec. So in this file, I have defined the what it should return and what it should do when the next method is called, depending on different context. So for example, in this one, you can see that when the input and ops stack become both empty, when you call a next method, eventually returns false. And you can verify this by if we change this true to false, we can see that it runs the test, and we can see that it was produced a wrong result when expected result should be this, and what my code produced was actually this. We can easily fix that by putting it back as it was before. And it runs the test again, and this time everything passes, and you can see the result. So that is just one example for one method. These are all of the behavior or the functions of each method in every class. So having the spec file in your project makes it easy for you to change your code later, and also add new functionality to your existing code, knowing that whatever you add to the existing code, and you want to make sure that everything you wrote before is still intact and your new code is not breaking any of the existing functionality you've written before, which is required somewhere else in the code base. I hope you enjoy the presentation, and I hope you like the video. Thank you.